Ask My Instructor 4.1.35. Find the critical points, if any, of the following function on the given interval. Determine the absolute extreme values of f on the given interval. Use a graphing utility to confirm your conclusions. The interval negative 13 pi over 6 to negative 5 pi over 6 is difficult to find because we are dealing with negative values and fractions. Take your time with this slide and really think about the numbers that are involved. For example, 13 over 6 is equal to 2 and a sixth. So negative 13 over 6 would be to the left of negative 2. Now let's look at the function. The derivative of the function is negative sine. Since the function is differentiable everywhere, we look for critical points by setting the derivative equal to 0. The derivative will equal 0 when sine is equal to 0. When is sine equal to 0? On the unit circle, the sine function is equal to 0 at the 2 points 1, 0 and negative 1, 0. And looking at the picture, I can tell very quickly that sine is equal to 0 when x is equal to 0, pi, and 2 pi. Unfortunately, those values don't help me. I'm looking for negative values. So let's go back to the unit circle and look for how we would express this as negative values. All right, so negative values. Well, negative values just mean I'm going in a clockwise direction. So sine is equal to 0 when x is equal to 0 or plus or minus pi, or plus or minus 2 pi, or plus or minus 3 pi. If we look at the given interval, we see that of the possible values of x where sine is equal to 0, the ones we want are at x equals negative 2 pi and x equals negative pi. So we have our two critical points on the closed interval. How does this help us? If a function is continuous and continuous on a closed interval, then we are guaranteed by the extreme value theorem that it has an absolute max and an absolute min on that closed interval. So this is what we do. We locate critical points. We evaluate the function at the critical points. We evaluate the function at the end points. And we choose our largest and smallest values. So to find the extreme values of the function on our closed interval, we will evaluate the function at the endpoints and at the critical points. There are two endpoints and two critical points, so we will evaluate our function at 4 locations. Cosine of negative 13 pi over 6 is the same as cosine of 11 pi over 6, which is radical 3 over 2. Cosine of negative 2 pi is the same as cosine of 0 and cosine of 2 pi, which is 1. Cosine of negative pi is the same as cosine of pi, which is equal to negative 1. Cosine of negative 5 pi over 6 is the same as cosine of 7 pi over 6, which is equal to negative radical 3 over 2. So, cosine of our endpoints is radical 3 over 2 and negative radical 3 over 2. Cosine at our critical points is 1 and negative 1. Which values are the largest and which are the smallest? The function takes on its maximum value at negative 2 pi, 1, and takes on its minimum value at negative pi, negative 1. Take care, have a good day, and let me know if you have any questions.